Good morning to everyone. I mean, although it's not a huge audience here right now, I think the important thing is if we can get these lectures delivered to everyone using technology at the end, well, that would give support to these type of initiatives, right? First thing, although I will be talking about the factories of the future, manufacturing 4.0, industry 4.0, and all that stuff, right? But also take into account that this is applicable to any other non-industrial related industry. For example, agricultural, the first part of the whole industry, how we seed, crop, and all that stuff, it's exactly the same, okay? I will be speaking basically about the transformation process, but for the first part of the process, it's also applicable, okay? First thing, I would like to give what we think is our vision of the factory of the future, right? And the whole ecosystem, from our point of view, is in 3 layers, structured in 3 layers. One of them, the first one, would be products of the future. How the products will interact with their ecosystem, with their customers, with their suppliers. From the product point of view, how do I have to change the way I define, design, and develop new products to incorporate all technology into that product? Okay, that's one layer. Second layer, which I will be focusing on that a little bit more, is factories of the future. How we will change the way we produce our products, okay? So we have the product, we have the way we produce the product, and then we have the smart ecosystem. The smart ecosystem includes the whole supply chain, okay, from our suppliers to our customers and the way we interact with those customers, right? So these 3 layers, which somehow take into account the impact of technology on those 3 layers, represent what we call the ecosystem of Industry 4.0. And we will be focusing a little bit more on manufacturing, okay? So, the goal of all of this, I mean, it's not because we are technology freaks, okay? Well, some of them are, right? But the basic goal is achieve what we call next generation industrial performance. That means not only in productivity or cycle times or lead times, but also in sustainability, okay? So all of these has a clear target. It's not a matter of getting technology for its sake of technology. It's a matter of being more productive, being faster in changes, in responding to changes, and being, let's say, socially responsible, because the sustainability includes the environment, but also the social aspects of that environment. So that's the basic goal, and we have to understand that this goal is what is driving all our efforts, right? It's not like some customers or some companies, excuse me, that sometimes introduce technology because it's cool, okay? You might think it's not the case, but there are many companies that introduce technology because it's cool. So, apart from those, and I assume that in this industry, in the agri-food industry, that's not the case. Apart from those, we all have to be quite focused on what we want to obtain, what we want to achieve by introducing technology, okay? So, what's our vision? And you will say, okay, there are 4 things there. None of them is sustainable. Yeah, none. None of them is productive. No. Why not? Because sustainability and being more productive is a result of these things. Okay? If we have a connected, virtual, smart, and automated factory, the result will be that it will be more competitive, more sustainable, and better integrated with the social fabric. So these are what we call the main levers for achieving next generation industrial performance. What does it mean? I mean, we can go through all of those, right? But basically, we will go through the technologies that help us here. Okay, this is the main levers, and then we have the second levers, which are technology in this case, right? First one, connected. What does it mean to be connected? It means that not only the machines are connected, but it's also connected to its environment, connected to its customers, to its suppliers, to the operators, and to the products. It means that we have a faster response to changes. It means that a customer could interact directly with our manufacturing environment. It means that we can interact directly with our suppliers because we're connected. Okay? That's one of the areas. The other area, which is integrating the real thing, physical thing, with virtual thing, which is sometimes called cyber-physical environment and things like that. I mean, I think everyone has heard about virtual reality. Well, most of us who have played with some type of game, we know what virtual reality is, okay? But this virtual environment, integrated with real data and with real physical environment, will give some, not all of them, but some benefits. For example, I can test manufacturing lines before they are built, because I just build them in virtual, interact with them in immersive reality, have my operators trained there, and once I'm sure it works, and it works the way I want it to work, then I issue the orders for real manufacturing of those. That's one example. The other example is that I can have people doing maintenance with remote support from someone 3,000 miles away, because we have what's called augmented reality, which will help us to obtain the best knowledge the planet can give us, allegedly, to do our tasks at any moment, integrating the real environment with a virtual environment. Third thing is what it's called the smartness of a factory, okay? Being smart means it can self-adjust, self-improve, and self-control. How? Basically, using machine learning, data analytics, all these type of technologies will allow our processes to self-adjust sometimes, not always. I mean, what's one of the main problems we have with this is what is called the latency. How many people does know that an automated line has milliseconds in latency? That means that you cannot wait 1 second to adjust the movements of, for example, a production robot. You can't. If it takes you more than that to run the analytics and change, it doesn't work. Okay? It means that we have to be careful in what we want to achieve with smart factories. And what we can achieve with that is better improvement, for sure, self-adjustment, but with a latency, okay, that is shorter than what we want to change. Sometimes I just get struggle, okay? I think that's one of the key issues, right? Because I've heard many things, and many people saying, no, machines and robots can self-adjust. No way. Not now. Not with the technology we have now, can't be done. It can be done in a different environment and with a different time frame, but not for the current operations with the robots, because the latency is so small, okay? And the fourth area in which we think that there's a huge advantage is the automation. But automation is part of the Industry 3.0, okay? The previous one, the third revolution. Well, you know, everyone, the first revolution is steam, second revolution is mass production, third revolution is automation and robots, and the fourth is information, basically. So this is part of the third one. But getting the benefits of the fourth one, which means, first, automation is connected. It's not isolated, automated production processes, but they're connected to each other. First benefit. Second benefit, we don't have to jail our robots to work. We don't have to have huge installations there of very dangerous robots that have to be isolated from humans because otherwise humans could get damaged. The second part of this revolution is that robots will work together with people. And we're seeing that a lot. You can see there are what's called cobots, collaborative robots, priced at about 18,000 euros, not more than that, that collaborate with humans. They don't substitute the human. They collaborate with the human in the most repetitive tasks. And then the human adds criteria to what has to be done. So it's a new way of interacting with machinery that will help, on one hand, getting the best out of the people, not just the repetitive tasks, more mechanical ones, but there are studies over there that say that between 40 and 60% of someone's job can be automated. But it's very difficult to automate 100% because there's some decision-making criteria that have to be met. And we still do not have the technology to emulate those decision criteria. Okay, so it's, of course, we will get better efficiency, better economy with all those things, right? But in the end, all these four areas will bring basically two benefits. One, more productivity. And you can measure that anyway. I don't care. Second, more sustainable. And you can measure that anyway. I don't care. I mean, up to you how you measure that. How you measure the sustainability in terms of environment, in terms of social, in terms of people. I don't care. So, these are the basic. And what are the basic technologies? Well, we group them in three clusters, three domains, I'll say. Okay. First domain, connectivity, which are, I mean, these three domains are, I wouldn't say independent, because they're not, but roughly independent from each other, okay? First one is connectivity. Second one is digital technologies. Third one is new and advanced manufacturing technologies. What's the first one? What we call the connected factory. But you need a lot of things for that. You need to have intelligent sensors. You need to have a way to connect all those sensors. Can you imagine how complex it is right now in any factory that has legacy equipment, 20 years old, 10 years old, which was not internet ready? How you connect all that into a platform that understands all the different protocols of each individual machine? Do you think it's easy? It's really crazy. You need a platform, software platform, that is able to first understand what these machines are telling you, a second, allowing to build what's called business rules on top of that, which means if temperature rises and we have a 2% yield and this happens, the business rules is reduce the speed. But to be able to do that in a complex environment is one of the critical things. That's why we say that technology from the connection, I mean the IoT, Internet of Things, is one of the critical things. Not because it's cool, which is cool, But not because being cool is something important. It's because otherwise it's almost impossible to get the best out of your machines. Okay? First thing. Of course, you have all the machines connected. What you do with that? Nothing. Well, cool, you have them connected. But if you want to get something, you have to be able to build on that. You have to be able to learn from that. So you have to run analytics on top of that. You have to have all the data and then be able to run the analytics semi-real time. That means very small batches to obtain the best out of it. So you need to have the algorithms, the technology that allows you to obtain the best out of your data. Otherwise, you connect your factory, you get the sensors, but you get nothing. Again, wasted time and money. Fourth thing, nice, I have sensors, connectivity, and I have the analytics. But if it's not secure, no one will implement it. Can you imagine the damage a single hacker can do in any factory? Can you imagine that? I mean, we're all used to saying that hackers in banks have a problem. That imagine someone playing around with our process parameters, with our orders, changing everything just for the sake of changing. Unless you have a very good security protocol and technology, this will not work, will not be implemented. Very nice, very cool, very impressive, very productive, will not be implemented because we're not secure. Okay? If we move on to the virtual and digital factory, then we will start getting some of the information, and all that information that is brought by the connected factory, we will start working with that. And we will start using, for example, factory simulation. What for? To understand what if scenarios. What if variability in this process increases? What if variability in the arrivals from my suppliers changes? What if demand increases? What if the mix changes? Unless you have good software tools and the way to integrate those software tools into your factory, you will not be able to run this analysis because factories are quite complex systems where everyone is used to seeing a value stream map. Okay? Value stream map is telling you more or less which are the value-adding steps in a production line, right? But one thing they have is that they're static. They're based on average. And a factory is much more complex than that. Factory has lots of variability. And that variability is a killer of productivity and many other things. So unless you are able to include that variability using discrete event simulation, it's almost impossible that you can run all these what-if scenarios. And of course you could tell me, okay, simulation has been around for a long time. Right, yes. The only thing is that you needed a huge computer. You needed specialist programmers to run that. Right now you can do it on your PC, portable. You can run 1 year factory working in about 3 minutes with your PC. And you don't need anyone with a postgrad in software. So things have evolved to a way that any engineer, any production engineer can use simulation tools. That's why I'm saying that it's part of the revolution. The simulation itself, no, but the technology is part of the revolution. Virtual factory, I almost said it all about it, how to render it virtual and decide what we want of our factory before it's built, actually. Augmented operator, same thing, but we have all seen the Google glasses and how we can have our information projected in the glasses and so on, but what if we can have this operator connected so that we can measure level of stress of the work he's been doing, that we can measure the vital constants. For example, what happens if you're a lone operator, if you're working alone? If no one's monitoring your conditions, you could have a problem, no one understands, no one sees that problem, you're dead. Stop. Every year we hear about events of someone dying because there was no monitoring of his condition. Every year. So that's also part of being sustainable and responsible from the social point of view. One of the critical things is that if there's a way that technology can help in that, we should be able to implement it. Do you know how much it costs to have a lone worker monitored? Excuse me? Not more than £1,000. Fully monitored. In 2 years' time, £100. Probably. Okay? That's one of the things. It's not only how productive we are, it's also how we care for the people. Our people and the others. And that's part of the augmented operator also. I mean, it's not because we want to monitor if he's productive or not, and because we want to record all his movements to see if he can be more productive. It's because we want to check if he's in the best condition to do the work. And if not, do something. And the last part of the virtual part is making things digital. That means that you don't need any paper around. That means that you're an operator, you have to do a quality check, and because you have a location based, you have a tablet that it tells you you have to review that, and that. These are the instructions. Check it, read it with the barcode included in the tablet. Take a picture if you want to check. And all that is immediately uploaded in your server. So you have to do no more work around. So somehow you reduce of course, the level of paper, but also you make things, you transfer the information to the point of use, which is one of the critical things. How do I convey all the information to everyone in a factory, making sure that he doesn't get more information than needed, but either that he doesn't get less information than needed. And that's the digital part of it. That's the interesting thing about it, okay? It's not just using 3D models because of sake of using 3D models. It's because it's needed somewhere in the factory. Last part, advanced manufacturing technologies. Okay, I'm on time. Good. That means basically 4 things. Advanced automation, I said before, cobots, collaborative robots, and so on, with robotics. But there are 2 other things, like advanced manufacturing technologies and advanced materials. I think everyone has heard about 3D printing, right? Which is part of additive manufacturing, really. Many people tend to confuse them. 3D printing is additive manufacturing? No way, no. It's just one technology of additive manufacturing. There are 17 different technologies in additive manufacturing, right? One of them is 3D printing. It seems that you might say, okay, it's not for me. I mean, I'm not growing grapes with a 3D printing machine. Yeah, probably not. But you will probably use it to manufacture spare parts, specifically in places which are difficult for access. If you can convey the information on how to manufacture that component, that spare part, and the company has an additive manufacturing machine there, you don't need to take the component there. You don't need to store the components. You just have the drawings, specs, and every time you need it, you manufacture that. That's one of the big advantages of it. Of course, we're never going to use AM, additive manufacturing, for screws, of course. Nothing that has a huge volume will, in the near future, you never know, will be manufactured using AM. But think of all the spares and all the troubles you will be getting rid of if you could manufacture your own spare parts. You wouldn't rely, you don't have to rely on the supplier in bringing that spare part to your location. You can do it anytime you want. Last part, materials. Everyone has heard about graphene, nanomaterials, okay? Fine, lovely. How do we incorporate them in our manufacturing processes? The standard manufacturing processes are not ready for this. So we have to work a lot doing R&D in how to incorporate all these advanced materials that might have a huge impact. These kind of films that can act as a solar battery, for example, or how to incorporate graphene in different materials, how to incorporate hybrid materials. It's not easy to incorporate that in our manufacturing processes. So this is another area of R&D that will probably help in being more efficient in the manufacturing. Okay, so these are the basic technology clusters we think will drive the change in the industry in the next 5 to 10 years. Okay, probably we will change in 3 years because things change faster than we do, right? But right now, this is what we think that will drive technology in the manufacturing. Okay. Next part of the speech will be how we apply these technologies specifically with one case I've prepared for each of those technologies. So you can see how it works. That's it. Thanks. Anyone has any question or whatever, or we will leave them for the
Thank you very much for your presentation. My question is related with the concept of this kind of industries and also the concept of smart cities. You know that some years ago, European Commission start talking about the concept of smart cities, and it's very interesting, but the implementation of this technology is being slow. You're right. Do you think that maybe in the industry 4.0 the implementation will be so fast, or it will be possible to learn something about the smart cities implementation?
Thanks for your question. Yeah, it will be much faster. Main reason? What do you imagine? The main reason? Private investment. There are no politicians around. Okay. The moment you don't have politicians messing around, you need something because you want to achieve something. You do it. That's why. I mean, and in fact, it's much faster. You see, investment in this area is about 100 billion euro per year in Europe alone, right now, which is a huge amount of money.
I just wanted to know, like, if are there many studies around about like how this may increase the gap between the developing countries and the developed countries, because all the people who already can have access to this technology are the ones who are going to take over manufacturing, which is now in developing countries, and that is the reason why they are developing and not underdeveloped, right? So it looks like the ones who are underdeveloped, they are going to stuck over there, right? And all these people with these technologies are going to take over the primary sector, right? The agriculture, also the manufacturing, also the services. So eventually, first world countries are going to be serving first world countries. and underdeveloped serving underdeveloped countries, no?
That's a tough question. You know how it all started, all this area? Where it started? It started in Germany. Okay? Why did it start in Germany? Because they were losing manufacturing capabilities. They wanted to recover that. Okay? Basically, manufacturing was moved towards developing countries. And the developed countries said, stop it. We need to recover that. So this was basically, and all this investment is mainly because the US, Japan, and Western Europe, basically, want to recover all that. And that's clear. The one thing about this, which is good, is that these technologies are available everywhere. And that's something that will, for sure, improve the capabilities of developing countries to be more efficient in manufacturing so that they can serve developing countries and developed countries. I mean, you know that one of the key problems is that if you have a manufacturing facility in, let's say, Western Europe, and it has to supply the developing countries, there will be a price problem, okay, clearly. So the way to make things happen is first making these technologies available to everyone so that everyone can implement them and then start serving with a decent price to the different areas of the world. I mean, there are some companies that do it, okay? Some companies have different prices depending where they're selling, and that's fine. But that's not the rule right now, okay? So, yes, that's a potential problem that this could increase the differences between developed and developing countries. But I think that it's also a huge possibility for the developing countries to grab these technologies and start being more developed. But that's an opinion. Sorry.
Well, thank you. I have a question about what's your vision about, you talk about an implementation in 5-10 years. It's quite a short period, and I would like to know what's your point of view of how this worker monitoring that you talk about will deal with privacy of the workers and the law about that?
Yeah, I mean, that's a spiky topic, really. It has to be very clear what this lone worker technology is for. If everyone understands that it's just to check their health and safety, and those data, again, are protected and so on, they're removed every time the shift finishes and all that, then might be, you wouldn't have any problems. But, I mean, imagine you're a worker, you're a lone worker, and you're afraid that something happens to you and no one comes to assist you, because no one knows. And then someone comes in and says, okay, if you connect this, you will be connected so that we can monitor if you're okay or not. And then we will erase all the data until next shift. Would you like to have this connection or not? Yeah, of course, I'm going to erase all the data. I mean, no one cares about your heart rate, really. I mean, I'm not going to publish that in YouTube. No one gives anything about your heart rate or your dehydration or whatever. I mean, it's not, of course it's sensible, or sensitive, excuse me, but no one cares. So I would delete them. Wouldn't you like to be connected or not? I mean, if I was driving, when I'm driving, and I'm driving alone, and I'm on a highway for 3 hours, 4 hours, I always think, if I have a health problem now, no one knows, I will probably die here. But if I'm connected to my car, and the car identifies that I'm having a problem, and then they call A&E, I might survive. So I would say, yes, please connect me. Increasing the chances of survival, that's all. But of course, we will have to deal with privacy, of course. But I mean, but it's implemented in some places, okay? This connected vest, yes. Okay. Last.
Yes, the last question is, you have worked during a lot of years in also in applying lean manufacturing in companies. What do you think about the potential of these technologies for improving the capacity of the ability of lean manufacturing, of improving performance in companies, and especially in the operation area?
I mean, lean will always be there, right? You will always be trying to remove waste, you will always be trying to be more effective, and so on. The problem is that you sometimes get to a, I would say, dead end. You need technology to go a step. So I don't see them as exclusive. I see them as being complementing each other. You use one until you get the best out of what your technology can bring you. Then once you've arrived to that dead end, you change technology. And then you start the working process again. You try to get the best out of the technology using Lean, Six Sigma, and all that stuff. Perfect. Until, at the end, you get again stuck. You change technology again. So that's the way I see it. I mean, it's an improving cycle from that point of view. Okay? So that was the last question.